Now, another thing that we want to care about when we're talking about user accounts, other than just elevated permissions, is going to be some of the simplest things like, well, how do I change a password? Right? If you sit down at a computer that you've never configured before and all you do is start out with a password of password, like, okay, that's going to be easily guessable, someone's already going to know this, etc. So definitely not a secure way to have our system. So the sandbox user for now, I'm going to leave that one alone so then me and you, we both know that this sandbox user is something that is easy to access, and I won't confuse us, and I'll keep that one as password. But I've got Bob now. So I've got the Bob user. What can I do to start modifying the password information for Bob? And of course, there's a command for that. So any user can change their own password. And they can do that through the passwd command, passwd. All right, so this is a command that will allow you to change your own password. All right, so if you log onto a system for the first time and you're unfamiliar with all the accounts, or if you think the account has an insecure password, like, well, maybe I should change it. And let's make sure you remember what you change it to. I don't know how many times I've seen people, they go, oh, I need to make my password more secure, and then they make it more secure, and then an hour later they forgot what they did. All right, and or especially in like a group environment, if it was a shared user account, you change the password and you never told your group members. So coming up with a password strategy, especially in a group setting, yeah, of course that's going to be important. So, all right, so we'll change the password here for Bob. You got to kind of type in your current password, verify that you are who you say you are. All right, and again, it looks like it's not typing, but of course, Linux just hides the characters on you. And let's see if I can come up with a slightly better password here that will be able to be just a little bit more secure. Okay, so I came up with something a little bit better than just my original password here for Bob. So yes, learning how to change your password, that's going to be a critical thing. Just, you got the passwd command. Now, I do want to emphasize here with the passwd command, you can change the password of another user account. All right, so if you just type the passwd command, that will change the password for your own account. But if you are capable of running sudo permissions, you can, emphasize this, if you're capable of running things with sudo, you can change someone else's password. All right, so let's try this as the sandbox user. As the sandbox user, I just changed Bob's password, and I changed it to a silly, like, hello123 with some uppercase and lowercase in there. All right, and so if I wanted to change Bob's password, maybe I wanted to like reset it back to password. Somebody forgot the password. If you have sudo permissions, you can always overwrite the existing password for another user. So again, as sandbox, I'll run this with sudo. This will require sudo because I don't want to change my own password. I want to change Bob's password. So I could do sudo passwd space and then Bob. So I'm not changing my password, I'm changing Bob's password. And as I run this command as sudo, it's like, okay, what do you want the new password to be? So notice it does not confirm, do you actually know the existing password? It's like, no, we're just going to go in and overwrite it. So let's see if it'll let me just change it back to something really simple like password. Let's see if I can completely reset it. Linux might be a little bit angry here. Sometimes it's like, nope, okay. So sometimes if you try to set your password to something too simple, like just the word password, a distribution like Ubuntu might yell at you and say, hey, you can't have a password that is that insecure. You need to come up with a better password. They actually have some password restrictions being enforced. But when you're overwriting someone's password, as we saw here, it just went and overwrote the password. So now if I wanted to log out and log back in as Bob, right, I could exit this and log back in as Bob, SU over to Bob. It's like, yeah, I'll have to be back to just typing my password of just password now. So you can overwrite a user account's existing password if that's something that you have to do at some point. If you ever lose access to a user account, it's always good to have some sudo-enabled user account that you have access to that would allow you to overwrite the existing password, try to regain access to these accounts. Password security is going to be absolutely critical, and group management is going to be absolutely critical as well. Now, as we're on this topic here of, understanding the passwd command, seeing how you can change a password for yourself as well as change someone else's password, I want to emphasize that there is a passwd file as well. And this is something that a lot of people get really confused on because there's a command that's passwd, and this is what you have to change your password. But there's also a file that's passwd. And a lot of people think, oh, that's where my password information is. It's like, no, not really. So even though you've got a groups command and there's a group file and they kind of seem to go hand in hand, it's like, well, there is a passwd file, but that's not the file that actually has your password information. So let's see what's actually there. Let's kind of untangle the threads here with the passwd command, the passwd file, and then finally the where is your password information actually stored. So let's take a look at it. There is a file in /etc called passwd, and again, when you take a look at it, it's a big long file. Right, you've got this big long file, and you've got lots of information in this file, but it's similar to the group file in the sense that, well, it starts with the very first thing. These now are going to be user accounts, right? That very first word that you have on every single line, that these are all different user accounts, and they're all separated. You can see this file has been parsed out. It's separated by colons, so every colon separates some piece of information. All right. And so, yeah, there are a lot of user accounts on the system. And again, these are not things that I created. When you install a Linux system, it's normal to have lots and lots of user accounts. Now, a lot of these user accounts are not used by human beings. They might be used by some service. They might be used by the computer. They're not something that you would sit down and log in at. And when you scroll down to the bottom of the list, it's usually towards the bottom of the list. These are where some of the newer user-created user accounts might be. So you can see here towards the bottom, we've got the sandbox user. At the very, very bottom, that's where I got my Bob user. If you went and added in some users, they'd probably start showing up here at the bottom of this file. But there are lots and lots of other user accounts that have been added, and that's what we can see here in the /etc/passwd file. Now, some information I would like to draw our attention to is kind of at the end of a line, right? So if I look at the Bob user, and I understand, okay, the Bob user actually has some ID number associated with it. We saw that with the ID command. It's like, well, when you take a look off a little bit further, one of the second to last piece of information actually says, well, that's where Bob's home is. Right, /home/Bob. So when we were learning how the tilde represents a user's home directory, in this file is where you can see what is the user's home directory been set to. So if Bob tried cding to tilde, it would come to this file and say, well, where is tilde for Bob? Well, it's /home/Bob. And we can see the same thing for the sandbox user. Right, the sandbox user had the home of, well, /home/sandbox. So the passwd file does have information related to a user account, but it's not the password information. All right, so try to not get those two confused. Yeah, the passwd is useful for changing your password, but the passwd file, it has user account information, but not actually your password. One of the last things to kind of note here is you'll notice how these files end, or each one of these lines. Each one of these lines ends with potentially something like this, like a /bin/bash. You see how sandbox ends with /bin/bash, and so does Bob. The Bob user also ends with /bin/bash. So we should understand for sure what bash is. Like, bash is the language that's currently running our terminal. So all the commands that we're learning right now, a lot of these like cd and ls and all the groups command and adding users, like these are commands that are built into the bash terminal. All right. So in other words, when you log in as the Bob user and open a terminal, the computer will look here to see what do you want to use to run the terminal. And bash is not the only thing. There are certainly other shells that you could get that you could use to run your terminal, but bash is one of the most common ones. So it's very common that you'll see things here like /bin/bash. All right, and that means that this is what the user is going to get when they try to pop open a terminal and log in. They're going to get a bash terminal. You'll see a lot of the other user accounts, they might have something like this, where it says /usr/sbin/no login. No login. So a lot of these lines that end with no login, what that indicates is that this is a particular user account that you couldn't actually go and log in with. All right, if you tried to drop into a shell on one of these other user accounts because of this, it's like, well, no, actually this user account has been disabled in that way. All right, so even if you had a user account that had a password and you could successfully type the password, that particular line here in this file, that would be a way to say, nope, the user's not going to be able to log in with that. All right, so useful thing to kind of know how to do if you need to disable a user account. This is one way. This is not the only way. There are other ways you might be able to disable a user account, but you kind of want to check to see, is my user account enabled or is it disabled? All right, and this might be one little hint. If I see this no login at the end of one of my important users, it's like, well, that could be the problem. Maybe it's just you don't know the password. Maybe it's the user account has been disabled and not necessarily deleted. Okay, so good things to kind of check for here in this file to be able to kind of check to see which user accounts are enabled or disabled or stuff like that. And there are other ways to be able to do that. That's not the only way. Okay, so I was mentioning password information though, right? We had talked about Bob here was actually able to go in and change his password, but the passwd file is not where the information is actually stored. So that begs the question, where is it stored? And yes, there is a file that actually stores your password information, and it's stored inside etc. And that file is called the shadow file. All right, the shadow file. So the shadow file is a really critical file when we're talking about password security. Okay, the shadow file. So let's see what this looks like. Let's see if we can cat it out. Can I cat out /etc/shadow? Let's give that a try. Ooh, permission denied. This is another file that's like, well, if you want to see what's inside the shadow file, you're going to have to be an elevated privilege user. All right. In other words, we're going to have to run this with sudo. So let's go ahead and add a sudo onto the front of this and say, let's cat this out. It's like, okay. What the heck am I looking at here? Again, it's looking very similar to some of these other files that have user information or group information. But as you look down through this, what we're looking at is what are the user accounts on the computer and what is the shadow file information that goes along with them. You have, again, separated by colons. Here's a variety of information. And as you get down towards the bottom, some of them look a little bit different. All right, you'll see here some have some different numbers in them. Some of them, it's like, whoa, my sandbox one has a whole bunch of information. All right, and same with my Bob user. So my Bob user and my sandbox user have way more information than something like the, I don't know, one of these like speech users. All right, something like this. So it's like, okay, so what's going on here? What does this mean? It's like, well, modern computer systems don't actually store your password. All right, that's a really critical thing to know, especially Linux systems, Windows systems, whatever. You know, modern computer systems do not actually store your password. What they do is they run your password through a hashing algorithm. And that hashing algorithm will create a representation of your password. And that's what you see here. That's what this output is here. All the way from this colon all the way to the next colon. All right, so when you put information in here in between these colons, this is an example of a hash. So we know the sandbox user's password. We know the sandbox user's password is just password. But the computer doesn't save that. The computer doesn't save password. What the computer does is it takes that word password, puts it through a hashing algorithm, and looks at the output. Okay, puts it through some fancy math. And then what came out the other side was all this. And so this is what the computer will save. And now when you sit down at the computer and need to verify that you are who you say you are, when you have to type in your password, the computer does not know did you type in the correct password until it takes what you typed and then it puts it through a hashing algorithm again. So the computer will save the output from when you first created the password, and that's what's stored here in this file. And then every time you log in, it will take what you type and put it through the algorithm again. And if the output matches, then it says, well, you typed the correct password. If the output doesn't match, then it goes, I don't know what the correct password is. I just know you didn't type it in correctly. All right. And so that's what we're looking at here with these two different users is these users are both users that actually have passwords. So it doesn't actually indicate here is the account necessarily enabled or disabled through the passwd file, but what it does say is this user does have a password that's been created. And so yes, you could have user accounts that don't actually have a password. And kind of an interesting one for Ubuntu is, well, actually the root user. The root user in Ubuntu right now does not actually have a password, so you'll never be able to successfully type in the password for this user account. When you try to type in the password, it doesn't matter whatever it is you type, you'll never be able to successfully type in the password because, well, this user doesn't have the password. All right. So you want to pay attention to what's actually in this shadow file. And from a security perspective, this is a critical file to maintain and keep track of. Like, we want to make sure nobody ever comes in here and tinkers with our shadow file. Nobody comes in here and steals it. All right. Certainly, if you ever hear on the news, like, potentially millions of accounts got breached. you should go in and change your account information, you should change your password information, whatever. All right, a lot of times what that means is the hackers have broken onto the server and they've stolen something like this. So do they know your password yet? It's like, well, if they steal this file, they don't actually know what your password is. But they can start guessing, right? This is where the brute force style attack comes in, or a dictionary style attack comes in. You get out your rainbow tables. You start doing password attacks against hashes to try to guess what the password is. All right, that's the real security of this, is if I give you this hash, there's no magic button to say, go back to the password. You have to just start guessing and comparing the outputs, okay? Now, a lot of times, too, what computer systems will also do is they'll also add some characters onto the front of your password. So you can kind of see here this for a particular user account like Sandbox. You see how it all starts out like this, $6, and then there's a bunch of characters, and then there's a final $sign there as well. All right, this is what we would call salt. Salt. So yes, when you have a password, the computer adds characters to your passwords without even telling you. So it takes the passwords and adds in this salt character. So if an attacker tried creating some pre-made list to try to guess your password, they would have to guess your password plus this additional salt. And so it just slows down if somebody ever stole your shadow file. It makes it a little bit harder for them to try breaking into the password. But anyways, this is something that actually got added in behind the scenes. All right. Now, the fun thing too about this is you can actually see how the computer calculates this if you just want to run a couple lines of Python code. So yeah, how about I show a couple lines of Python code that will actually show you how this line right here is generated. And the fun thing about when you're running in a bash terminal is you can just type the Python command and it will drop you into Python programming mode. And on modern computers, you might have to type Python 3. So on a lot of computers, it's been bound that if you just type Python, that will work. On modern Ubuntu computers, sometimes you just have to type a newer version. And these probably have Python 3. Yeah, so Python 3 will work. Okay, sometimes you have to type Python 2. Usually it's just Python or it's Python 3, kind of depending on what distribution that you're actually on. Okay, so the point is, though, now I'm not running bash commands anymore. I'm not doing things like ls and cd. It's like, well, now I'm running Python code. And Python has some really interesting built-in libraries that will allow you to simulate what is it like to actually go and calculate one of these hashes, so we can actually see how this has been generated. All right, and so the library that we need to use in order to do this is the crypt library, import space crypt. And this is a cryptographic library that contains a whole bunch of things, including hash calculations. All right, so let's try that. I'll say import crypt. Okay, doesn't look like anything happened. That's okay. It means we just brought in this crypt library. And now what I want to take a look at is, well, how do I go about generating a hash using this crypt library? And the answer is, well, we call a crypt function. So let's say the function is crypt.crypt. We'll do an open parenthesis, and inside here, the way this crypt function works is you have to give the crypt function what is the password and what is the salt information. And if you put in the password information and the salt information, the Python code will go and will generate the hash, just like what happens whenever you go and log into the system. So let's go ahead and try this for our Sandbox user. And so I know my password right now for the Sandbox user is just the word password. So I'll put that in quotes. I'll then put a comma. And then in quotes again, I'll have to type out what this salt information was, this $6, and then all the way to the third $. That's the information that I want. And I'll kind of cheat here. I'll use the GUI. I'll do a right click and copy. I'll copy the information and I'll bring that down and I'll also put that inside quotes. I'll open the quotes, say a paste, and then close the quote and then close the parenthesis. Let's give that a try. All right, so we're going to try running some Python code here that is going to take the word password. It's going to combine it with this salt information. This is stuff the computer added on without even telling us. And let's see what the output is. It's like, boom, there's the output. Okay, what is all this out? Well, take a look up top. Take a look up top. Okay, so we can see the $6 all the way to that third $. That was generated again. Here it is. And what came after the $? It's like we got JGGMVRN, and you can look up here, JGMVRN. Like, yeah, it's typing out the same thing. Look at how it ends. right? You've got slash FDBCT. I'm just kind of looking at some of the last characters, and here they are again up top. Slash FDBCT. It's like, yeah, this is the same thing. All right, so your computer, when you log in, it runs code similar to this. It takes the password, whatever you typed, it takes the salt information out of that shadow file, and then says, well, here's what we got when we combine those things using the hashing algorithm. And if it matches what's in the file, you're good. You typed the correct password. If it doesn't match what's in the file, it's like, I don't know what the password is, but you did not type it correctly. All right, so let's maybe give it a try and see what happens if we were off by one character. Maybe I'll use a capital P for password instead of a lowercase p, right? So we'll do a crypt, C-R-Y-P-T, crypt.crypt, and this time I'll use a capital P password. And then we'll close that, open the next one, and I'll paste this text in again. We'll use the same exact salt. Everything's the same, except this time I used a capital P instead of a lowercase p. Let's see what happens this time. And we'll see it's like, okay, we put in the salt information, and now what comes after the salt information? Now it started slash QCVOZ. It's like, yeah, way different. Okay, not even close. Look at how the thing ends, right? Slash FDBC, and this one ends 1HI1F, like not even close. All right, you're off by one character with your password. The hash is going to be completely wrong, and then it says, nope, you're not allowed to log into the system. All right, so understanding the shadow file and understanding how these hashes work, is really critical to password security. And this also gives you kind of an inside look as to how do password crackers actually work. A lot of those brute force or dictionary style attacks, how do they actually work? The question now becomes, well, how good are you at Python? Okay, do you know enough Python code to make a little Python loop? Okay, if you could make a little Python loop, you could just start looping in what are all the passwords you want to guess, right? Let's run the crypt.crypt code and toss in a password as a variable. Check what the output is. If the output matches what the output is in the file, hey, we found the password. If not, go on to the next password. All right, and so something like that is a really simple, really straightforward way that, yeah, you'd be able to make in just a couple lines of code kind of your own password cracker to try guessing hashes out of a shadow file. All right, now, yeah, of course, there's tools that already do that, and absolutely I'd recommend using the tools, but sometimes it's kind of a fun way to just sort of learn how to make your own and see how this works. Now, when you're all done with Python programming mode, it becomes useful to know, like, how do I just go back to the command line? All right, and you have to run the quit function. All right, so if I run quit and then open parenthesis, close parenthesis, that will quit out of Python programming mode, and now I'm back to now I'm back here to just the desktop here. All right, so we can try to do this for one of your Sandbox users or for one of your Bob users, go in and see what the password information is. And if you wanted to get super crazy and totally mess with things, it's like a super complex, very much not a recommended way, but it's kind of a complex way you could overwrite someone's password. Right? If you had this knowledge, you actually could generate a new password this way and then just put this information in the file. Just, don't screw it up, because if you screw it up, of course, then now that user can't log in properly. But it is kind of a tricky way you could generate the information necessary to actually forcibly change someone's password. But, we don't want to be doing this every time. That's why we have the passwd command, right? We change someone's password with passwd, but once you understand how the file works, like, now you can go into the file and take a look at it for yourself.